Hi students, have a nice day. In this section we are going to discuss about the isomerism. Different types of isomerism. What are isomers? Isomers are the compounds have same molecular formula but different properties. Okay, so what are isomers? Compounds having same molecular formula but different properties are called isomers. And the phenomenon is known as isomerism. Okay, the phenomenon is known as isomerism. Okay, isomerism is broadly classified structural isomerism and stereoisomerism. Okay, so the first classification is structural isomerism. So we have to broadly classified into structural isomerism. And this is stereoisomerism. Stereoisomerism. Okay, what are structural isomerism? Compounds have same molecular formula but different structures are called structural isomerism. What are structural isomerism? Compounds have same molecular formula but different structures are called structural isomerism. And the second classification, main classification is stereoisomerism. Okay, stereoisomerism. In stereoisomerism, the compounds have same molecular formula but different spatial arrangement of atoms or group of atoms bonded in the molecule. Once again, compounds have same molecular formula but different spatial arrangements. Okay, spatial arrangement is different in the three-dimensional figure or three-dimensional notation of the molecule. Okay, so spatial arrangement of atoms or group of atoms are different. The isomerism is known as stereoisomerism. Okay, then structural isomerism and the stereoisomerism again classified, again branched. Okay, in structural isomerism there are mainly four isomerism. Okay, one is chain isomerism. Chain isomerism. And the second one is position isomerism. Position isomerism. And the third one is functional isomerism. Functional isomerism. The fourth one is metamerism. Metamerism. And two more addition is tautomerism. Tautomerism. And the sixth one is ring chain isomerism. Ring chain isomerism. Are you clear? Yes. Structural isomers are compounds have same molecular formula but different structural formula. Are you clear? Then in structural isomerism, there are mainly four: chain isomerism, position isomerism, functional isomerism, metamerism. Tautomerism and ring chain isomerism is not in the syllabus. You have to study for entrance or competitive examination. Then a stereoisomerism. Stereoisomerism is classified into one, geometrical isomerism. Geometrical isomerism. Okay, in that cis-trans isomerism. Then next is optical isomerism. Optical isomerism. Okay, the compounds have same molecular formula but they can rotate the plane polarized light into different direction. Some compounds rotate the plane polarized light into right side and some other compounds rotate the plane polarized light into the left side. Okay, dextro and levorotatory. Dextro means right, levo means left. Okay, you will discuss, you learn these in the +2 classes. Okay, in +1, the structural isomerism, stereoisomerism. One more isomerism is in the stereoisomerism, it is conformational isomerism or conformation. Okay, the carbon-carbon single bond rotate, different orientations, different spatial arrangement is obtained. So such isomers are called conformational isomerism, and the phenomenon is known as conformation. Okay, so geometrical isomerism and conformational isomerism we will discuss in the next chapter, hydrocarbons. Okay, hydrocarbon chapter we will discuss the geometrical isomerism and conformational isomerism. Optical isomerism is discussed in the +2 classes. Okay, so you should learn these, otherwise you feel difficulty in the +2 classes. Okay, these are the classification. Then let's discuss one by one with the suitable examples. Okay, hope you understand what is isomerism, then a different type of isomerism. Then we will discuss about different structural isomerism in this chapter. Geometrical isomerism and conformational isomerism discuss later in the next chapter. Okay. Yes, first one is chain isomerism. Okay, the first one is chain isomerism. The definition of chain isomerism is very simple. Okay. Yes, the first one is chain isomerism. Chain isomerism. Isomers have same molecular formula but different properties. So here the chain is different. Molecular formula is same. Okay, so we will define the chain isomerism. Compounds have same molecular formula but different structural chain. Okay, compounds have same molecular formula but different structural chain is called a chain isomerism. Sometimes it is also called a nuclear isomerism. Okay, nuclear chain isomerism. Let's take one example. CH3, CH2, CH2, CH3. What is it? It is N-butane. N-butane means, what is the small letter N denotes? Normal butane. N-butane. The formula is C4H10. Okay. With the same molecular formula, but different chain, isobutane. CH3, CH, CH3, CH3. Okay. Out of two hydrogen, one hydrogen is moved to this carbon and this CH3 is come into the second carbon atom. We get CH3, CH, CH3, CH3. And it's called isobutane. Isobutane. The formula is same. Okay, are you clear? The formula is same. C4H10. 4 carbon atom, C4. 3 plus 2, 5. 5 plus 2, 7. 7 plus 3, 10. Similarly, same number of carbon, same number of hydrogen, but the chain is different. Same molecular formula, chain is different. So this is an example of chain isomerism. Okay, only one example is given in your textbook. I will give that example. Okay, pentane. This is not provided. Next is pentane. CH3, CH2, 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 CH3. Okay, 1, 2, 3, 4, 5. What is the name? 5 carbon atom, all the bonds are single bond, so the name is pentane. And we put N Okay, in common name the N is must. Common name it is pentane. Okay, IUPAC name pentane. N-pentane means normal pentane. Straight chain that denote the normal letter N. Okay, another, the 5 carbon in the straight chain is branched. CH3, CH, CH3, CH2, CH3. Okay, one of the methyl group comes in this carbon or this carbon, no problem, both are same. Okay, and this is isopentane. Isopentane. Okay, what is the IUPAC name? IUPAC name of this is pentane itself. Okay, pentane itself. What about this? This is we number 1, 2, 3, 4. Okay, so from these two left side, right side to left side, the methyl group will get the third position. So this numbering is correct. What is the IUPAC name? This is common name. Okay, what is the IUPAC name? IUPAC name is 2-methyl-butane. 2-methyl-butane. Are you clear? Okay, this have straight chain, that's why we put N-pentane. The IUPAC name of N-pentane is pentane itself. Then CH3, CH, CH3, CH2, CH3, branched one, same number of carbon atom, all having C5H12 molecular formula. Okay, this have C5H12, this molecule have C5H12. Then one more branching. This hydrogen is migrated to this carbon and this methyl group comes here. So the formula is CH3C, CH3, CH3, CH3. Okay, this is also possible. So 5 carbon atom in the chain, 4 carbon atom in the chain, 3 carbon atom in the chain. Okay, degradation in the carbon chain. Not in the carbon chain, in the structural chain. Then it is called a neopentane. Neopentane. Neo means new. Okay, neo means new, pudiyada. Then what about the IUPAC name? 1, 2, 3. 1, 2, 3. 1, 2, 3. Maximum is 3 in the parent chain. Okay, so 1, 2, 3. The IUPAC name is 2,2 dimethyl propane. Okay, you don't write the name separately. It's very important the weights are grouped together. So here there is no space. That's why I broken the weight. 2,2 dimethyl propane is a single line. Okay, you should keep in your mind. Second carbon atom, 2-methyl group. Okay, so this is about the structural isomerism and the particular example is chain isomerism. Okay, are you clear? Butane, isobutane. What is the IUPAC name of this isobutane? N-butane is butane itself. What is the IUPAC name of this? 1, 2, 3. Okay, 1, 2, 3. It is 2-methyl propane. Formula is same. I write here. IUPAC name. 2-methyl propane. Okay, 2-methyl propane. Are you clear? Yes. Then we move to the next one, position isomerism. You can practice hexane. Okay, you practice hexane. Yes, the next isomerism is position isomerism. Second one is position isomerism. What is position isomerism? From the name itself, we can understand one thing. The position is different. In chain isomerism, same molecular formula, but different chain. So, what is a position isomerism? Compounds have same molecular formula, but different position of functional group or substituents or double bond or triple bonds. So we can define the position isomerism. Compounds have same molecular formula, but different position of functional group or a substituent or multiple bonds are called position isomers, and the phenomenon is called position isomerism. Once again, compounds have same molecular formula but different position of functional group or substituent or multiple bond are called position isomers, and the phenomenon is known as position isomerism. Okay, let's take the example. CH3, CH2, CH double bond CH2. Okay, what is this? But 1 in 1, 2, 3, 4. Then it's position isomerism. Without change the chain. Chain is not changed. Chain is same. 4 carbon atom in the chain. Here also 4 carbon atom in the chain. But the position of double bond is changed. But 2 in. Not read but 1 in, but 2 in. But 1 in, but 2 in. So this is a position isomerism. Another example. CH3, CH2, CH2, OH. Okay. 1, 2, 3. Alcohol family. So a functional group will get the lowest possible number, first position. So 1, 2, 3. Okay, 1, 2, 3. This is propan 1 ol. Okay, 1, 2, 3. This is prop group, propyl group. And the first position OH group, so propan 1 ol. Propane is dropped because the secondary suffix start with a vowel. Okay, so it is propan 1 ol. And the position of functional group changed without changing the chain. Chain is same, 1, 2, 3. 3 carbon atom in the chain. But the position of functional group is changed 1, 2, 3. 1, 2, 3. In either direction, the position of functional group is 2. Okay, so this is propan 2 ol. Okay, propan 2 ol. Are you clear? Another example. CH3, CH2, CH2, CH, CH3, CH3. Starting from the number 1, 2, 3, 4, 5. It is 2-methyl pentane. 2-methyl pentane. And another molecule. CH3, CH2, CH, CH3, CH2, CH3. From either direction, the position of substituent is 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In both directions, it is third position. So, 3-methyl pentane. Look at the name. 2-methyl, 3-methyl. The others are same. Here also, propan 1 ol, propan 2 ol. The position is different. Here, but 1 in, but 2 in. Position is different. So what is position isomerism? Compounds have same molecular formula but different position of functional group or substituents. Clear? Yes. The next is functional isomerism. You can collect more examples. Okay, I think in a book, NCERT book, only one is given. You collect more example, practice it, and you will clear the idea. Okay. Then next is functional isomerism. Okay, functional isomerism. The third one is functional isomerism. So chain isomerism, different chain. Position isomerism, different position. So what is functional isomerism? Compounds have same molecular formula but different functional group in the molecule or in the compound. Okay, once again I define. Functional isomers. Compounds have same molecular formula but different functional group. And the phenomenon is known as functional isomerism. Okay, yes, let's discuss some example. At that time you can understand the concepts. CH3, CH2, CH2, OH. Or we can take one simple example. CH2OH. It is alcohol family. The common name, isoprene. Common name is ethyl alcohol. Ethyl alcohol. IUPAC name is ethanol. Then the formula of this molecule is C2H6O. What is the molecular formula? 2 carbon atom, 3 plus 2 plus 1, 6 hydrogen, 1 oxygen. Okay, with the same molecular formula but different functional group, one compound is there. CH3, OCH3. Formula is C2H6O. But the class of compound is ether. Okay, the class of compound is ether, The class of compound is ether group. Ether. Then the common name of this molecule is dimethyl ether. Dimethyl ether. COC link is ether link or ether functional group. On either side of this oxygen, it is methyl group. So that's why dimethyl ether. Okay. But the IUPAC name is methoxymethane. One of the group is considered as a oxy group. So methyl group and oxygen methoxy. And one carbon hydrocarbon. That's why methane. Okay, once again. If either functional group comes, the smaller alkyl group taken as a alkoxy. Smaller alkyl group is taken as alkoxy and a higher alkyl group is taken as alkane. Here both are same number of carbon atom. So you take any one alkoxy group, then methyl group and oxygen methoxy. One carbon atom hydrocarbon is methane. Are you clear? This is one of the functional isomerism. Another one. CH3, CH2, CHO. 3 carbon atom and aldehyde group. Okay, it is propanaldehyde. Common name is propanaldehyde. and its IUPAC name is propanol. When aldehyde group is a functional group, the secondary suffix is al. So 3 carbon atom, al, propanol. Okay, common name is propanaldehyde. Okay, propanaldehyde. Then the formula of the compound is C3. Okay, C3H6O. Another molecule with the same molecular formula, CH3, C double bond O, CH3. Okay, CH3, C double bond O, CH3. And the common name is acetone. I think you heard about acetone. It's a solvent. In many industries it is used as a solvent. Acetone. And the IUPAC name is propan. When ketone comes, it is on. Propanon. So propanol and propanol are functional isomers. Because one molecule having or which contain aldehyde as a functional group and the other which contains ketone as a functional group. So what are functional isomerism? Compounds have same molecular formula but different functional group present in the compounds. Okay, hope you understand about the functional isomerism. In your textbook, this is given. You understand the other example. Okay, you collect more example and that's why you can make a clear idea about the isomerism. Okay, and the last one. Okay, last one, metamerism. Metamerism. It's a very simple isomerism. Metamerism. Okay? Metamerism. First I write the example, then we can define. That is an easy method. CH3, CH2, O, CH2, CH3. Okay, it is diethyl ether or it is ethoxyethane. IUPAC, this is common name. Ethoxyethane is IUPAC name. Because ether group, what is ether group? You know that COC link is ether link. So COC link, ether comes. Common name is diethyl ether. Both side ethyl group. So that's why diethyl ether. But in IUPAC name, smaller group is treated as alkoxy. Here both are same carbon atom, 2 carbon atom on either side. So that's why ethoxyethane. The formula of the molecule is C4H10O. Okay, C4H10O. With the same molecular formula and the same functional group, but the compound is different. Okay, CH3, CH2, CH2, O, CH3. This oxygen comes between in these 2 carbon atom and this carbon joined to the carbon. Okay, so CH3, CH2, CH2, O, CH3. Formula is same. C4H10O. 3 plus 2 plus 2, 4 plus 3 7, 7 plus 3 10. 4 carbon atoms, 1 oxygen. Formula is same. Same functional group. Formula same. Same functional group. Then you can see what is the difference. The difference is alkyl group. Okay. The difference is the alkyl group. And these isomers are called metamers. And isomerism is known as metamerism. So what are metamers? What are metamers? Compounds have same molecular formula but different alkyl or aryl group. Or now you can understand different alkyl group. Different alkyl group on either side of the same functional group. Okay. Same functional group, same molecular formula, but different alkyl groups on either side of the same functional group. What about this molecule? It is methyl N-propyl ether. It is common name. Okay. Methyl N-propyl ether. This is methyl group, this is N-propyl group. And the iupactane, this is long chain, 1, 2, 3. Is taken as alkoxy. So methyl group and oxygen, methoxy. 1-methoxy propane. It is iupactane. Okay, once again, two different alkyl groups. You take the smaller alkyl group as a alkoxy. So here methyl and propyl. Methyl group is a smaller alkyl group. So methoxy. Methoxy. And where the methoxy group is attached? In the first carbon. That's why 1-methoxy propane. Similarly, another example. CH3, CH2, NH, CH2, CH3. The name of compound is dimethylamine. Dimethylamine. And these same functional groups. Functional group is same. CH3, CH2, CH2, NH, CH3. As similar happens in this example. So one side is methyl group, another side is propyl group. So what is it? Methyl N-propyl amine. Okay. So a very simple concept. You understand the concept. Compounds have same molecular formula but different alkyl or aryl group present in or attached in either side of a same functional group is called a metamers, and the isomerism is called a metamerism. As I already told you, a stereoisomerism, that is geometrical isomerism and a conformational isomerism, we will discuss in the next chapter. Optical isomerism is comes in +2 classes. Okay, that's about the isomerism of organic compounds. We will discuss another concept in the next section. Thank you.